And our next speaker is from a company that actually uses standardization. So maybe to put it provocatively, he can actually help us assess if it's all helpful or not. Anyway, our next speaker earned his diploma in mechanical engineering from the Ruhr University in Bochum. He then gained industrial experience at Reis Robotics, Hahn Automation, and Engel, Austria. And since 2017, he's been leveraging his expertise in product development, robotics, and laser technology. Please welcome the Director for Automation at SumitomoDemag, Jürgen Schulze. Round of applause for you, Jürgen. Jürgen, hello. Welcome.
Thank you.
I think you need this. The stage is yours.
Very important, yes. Yes, hello together. The second time that I'm here on this meeting at the PI community, and I want to present or show our experience with robotics on our core business, injection molding machines. SumitomoDemag is a typical machine builder. It's a Japanese machine builder. And so some facts and figures to Sumitomo Heavy Industry. This is our Japanese headquarter. And this is in Chiba, very close to Tokyo City. And we are part of Sumitomo Heavy Industry. We are a part in the PMD, it means Plastics Machine Division. We are in the Plastics Machine Division approximately 3,700 people. And we have turnover in the last year of approximately 640 million euro. In global, Sumitomo Heavy Industry have more than 70,000 employees. We have installed in the last 15 years more than 160,000 injection molding machines worldwide, and our market share is in all relevant markets approximately 10% as minimum. We are SumitomoDemag. We are focused for the markets in Europe and in America, North America, Central America, and South America. And our product range, yes, our core business are injection molding machines, and we are very focused on all electric machines. This is the Intellect, the Pace, and the Alexis one and the Systec one. They are more hydraulic machines. They will phase out in the next years. And for the automation, we have developed in the last years our own series. We called it the SAM series, Sumitomo Automation Machine. And we have additional elements for this automation, as example, a brand-labeled product from a French supplier. But our focus is mainly the handling system, very close to our process machine. And we are focused on more smart and easy automation. And we think we have, from our strategy side, for the robotics and automation, more than 30 years experience with robotics and automation. We are focused on, with our SAM strategy, on simple and user-friendly automation elements. And for complex automation, we have a strong network of more than 500 experts. Before I want to report what we have done in the last years, I will show you a typical molding process together with an injection molding machine, but the newest development from our side for the robotics. We say we have process-adapted robotics because the standard robotics is not the focus for us in the future, because we have changes in the generation X, Z, and the Alpha, which are coming. And what you now see is a typical process. This starts with the demold of the parts in the tool, the separation of elements, scrap parts elements, or cold runner elements. Then we quality check of the parts, and then a separation in bins with special inserts. On the right side, you see a flow chart of the process. Please, this is not now in discussion in this presentation and with this movie. It should only show you a rough overview how this process works. And I start now the movie. We are very focused on robotics with linear axis because we have, in this case, the possibility to independently move this axis. You see now the separation of this cold runner. This is a real 6-axis robot with a 6 degrees of freedom. This is the quality check, in this case with a video system. Then the separation of the 4 different parts in inserts. The process cycle time is approximately 28 seconds. The shortest production cycle for our machines is with automation approximately 4 seconds. And this is the first input for you, what we do and why we develop our own robotics for our machines. A standard application with a 6-axis robot and with a standard linear robot is possible, but for a lot of operators, not the best way. As I joined in year 2017 SumitomoDemag, I was a little bit afraid about the situation. We had a strong business with injection molding machines. We was well known as an excellent machine builder, but we had no acceptance in the market as system supplier. So we analyzed the situation from the technology side, from the standardization, and from the demography. The plastic industry is really well standardized side in middle of the 1980 years. It starts with the FHK interface between the machine, and in the meantime we had a lot of standardization for the machine, for the periphery and so on, and for the robotics too. And we analyzed the situation, why we have so a weak situation since the beginning of the 2000 years. And it was not so a surprise for us that the influence of the change in the generation have a big impact in our business. We work with robots, linear robots, and later with 6-axis since 1995. And as example, in year 2000, you can remember the smart production in Strasbourg, the first 6-axis robots together with injection molding machines. For us, it was a little bit surprising that the generation Z in the communication with the smartphones and so have a big impact of our industry. It's very important for this generation to have a direct reaction of situation on the machine, on the process. The older one, the baby boomer, adapted mechanical elements on the machine. It was not so the problem. But additional with the appearance of the cobots, we see that not the mechanics of the cobots was so had a big impact. It was the kind of programming of robots. And so we started in the year approximately 2018 with the development of our SAM strategy. And this was combined with special kinematics around of the injection molding machine. And the idea was absolutely to combine the new kinematics with the kind of programming very similar to the cobots. And that is what I now want to present. What is the result of this? The main needs for us on the injection molding industry or plastic industry was easy to use. This means easy programming, easy handling with the mechanics, easy understanding. So you have short training lessons for this. In Unifit design, this means very standardized, scalable design of the robots. Universal applicable. We have a consumer market, we have a medical market, we have an automotive market, we have a market of electrical and electronic elements. The packaging market, always a large discussion, footprint in the production, to have the compactest production sets, what is possible. And with the shortage of skilled workers, always the discussion for higher autonomy of the production cells. For us, additional, we want to have a better corporate identity of the products of robotics automation together with our machine. So we decided to develop our system after the market analysis. And on one side, we have our idea of a special kinematic of the 6-axis robot. On the other side, we have a lot of applications with standard linear robots. The advantage of the linear robot on the injection molding machine is the workspace of the injection molding machine is more a cube. The workspace and or the envelope of a Cartesian is very similar. In this case, it's very simple handling for the operators, and the operators not experts like you. It's sometimes, not so qualified persons, and it's more and more different to have such persons in the production. Our idea was not to develop the mechanics. For this, we are selected expert partner. From the electronic side, we use the same elements as for our injection molding machine. The reason was to shorten the time to the market. We are focused absolutely in the function design to develop the robotics software, what we have understand from the market. We use from our company, from Sumitomo Heavy Industry, the motors and the reducers, and we combine the mechanical body together with the cabinet and with the software in our factory in Vier, and added additional customer options. This is the story of the SEM on this point, and what I think after 5 years experience is the real value, the real pearl of this development is the development of the software. Because we use the same touchscreen as for the robotics programming as for our process machine. We use a lot of graphic elements for simple understanding for the operators. And we have realized a real low-code programming, and this starts with a flowchart generator. We have installed 3 basic recepts. The operator can use this, can copy this, can change this, storage with a new tool number. And our experience from the, we have installed the pre-series by our customers in our subsidiaries is, it's very simple to program the robot because it's helpful step by step. It's a good understanding, and we have the experience that in our training center, after 2 or 3 hours, it's possible to combine the robot program together with our process machine to a real production cycle. This is now what I want to remember now. This is the flow chart of the process of this movie. And he looks very complex, but in the starting, you edit elements very similar. Okay, he don't like me. And you see on the right side, inside of these elements, we have blocks. And these blocks are to parameterize, or positions is to teach. And this is the total running program. You have no text, what you have to insert, you have no programming lines. You have no special program language. You have here a real low-code programming. Yes, what is the result of this? From the mechanic side, we have here as an example, we called it handle and place. This is our process machine together with a simple handle and place solution. And we have here, we called it handle and box. This is the next level. We have here additional storage system behind of the process machine for ghost shifters, weekend work. And we have realized easy to use from the programming, from the handling. We have this standardized design. We have 4 payload classes for the Cartesian robot. We can universal applicate this solution in different industries. The footprint is the best what we ever had. It's very integrated in the machine. You see these elements, the electrical cabinet on this position as example. It's the safety and this standard solution always with CE, conformity. What is our next step? Yes, the next step is the final development of our special kinematics. Why we think it's a game changer for us? And you see, as example, this could be in SAMC, this field with the red line. This is the space predefined of the 2 main axes in the vertical and in the horizontal. And related to the SAM-S, you have the total other possibilities. You have a more oval space for the operator, or better for the machine. And this is a higher possibility for applications on the injection molding machine. You can add more periphery for different products. You are more flexible. And we have checked this on the K-Show 2020 and now this year on the NPE show in America with a concept study to collect feedback from the market, from possible customers. And the feedback was very positive, yes. And this is in work, this concept. And we have here the advantage that we have 2 independent linear axes. If you have a problem in the tool, you lose a part, as example, the robot stopped, is not longer in the automatic cycle. For 6-axis robots, we have always the discussion that we must a home run program in this situation. For this one, if we have we have no collision points, the simple operator can use about the control to move the vertical axis outside of the tool. And if you understand the tool complexity in the injection molding machines, we cost more than 200,000 euro, or a gripper costs more as 50,000 euro. You understand if something happens, an operator in the night shift, he will never make a change or on this machine. So it's very helpful to have here a solution between the linear robot, the 6-axis robot, related to the operators, the qualification of the operators in the future. We have here compared the system, what you have seen in the movie, against the standard linear robot for us. The green field is the real working envelope on the machine for the linear robot. And you see these red boxes. This is the workspace for this special robot, the SCAR robot. And here is the ratio of 1 to 11 of the workspace, what is possible. This is the reason why we develop for us, for our machines, this special robotics. Yes, for the future, and this is one reason why I'm here. We see future potential together with these universal or standardized interfaces as SRCI to transform our know-how from our process know-how to other process know-how, together with our mechanics in other industries. Yes, these my words for today. Thank you very much for your attention.
Thank you very much, Jürgen. That was great. I saw a few eyebrows go up when you showed the strategy slide with the timeline. It was complex, but I think you broke it down excellently. And also that video you showed really helped me, especially picture what you're doing at the customer side. So thank you. I think we can fit in one short question, and then maybe we can, or you, Jürgen, can speak during the networking break with a few other people.
Yes.
So again, hands up, and whoever's quickest will get the microphone. Do we have anything for Jürgen? Yes, we have one here. Microphone is coming. Thank you.
Yeah, thank you for a nice presentation about your way to design your own hardware, but do you also offer software tools like simulation, virtual commissioning, because it's kind of complex programming or verification? Is it also in your agenda, or is it something
Yes, absolutely. Absolutely, but we currently work on our SAM software, because our idea is to use the SAM software for all kinematics what we want to adapt to our machine. And a very important point is the offline programming for such systems, because you cannot wait for a program. And yes, this is always in R&D. Especially for this, for the simple solution with the linear robot, we use this with our same hardware elements, not on a PC, with the same hardware elements that we have. So we trained our customer on our linear robots, and this will be the way for us for simulation to add this for this special robot kinematics, but. We have now worked 4 years, and the other one, the competitors, have more than 30, 40 years advantage against us. So we try it, but it's need time.
So we can wait for it, right?
Okay. Thank you very much. And yeah, if there's any more questions for Jürgen, feel free to ask him those during the networking break, because that's where we are now. Please be back here in about 15 minutes. Online audience as well. Feel free to dial back in. We'll keep the stream running. So thank you again to Jürgen. Round of applause. Thank you.